the next conic section we're going to look into is the parabola, and I want you to be able to determine if a parabola is horizontal or vertical. To graph it, identify its vertex, its focus, its directrix, its axis of symmetry, and the length of its latus rectum. So in Chapter 5 you worked with quadratic functions, and the graphs of quadratic functions are parabolas. In Section 10.5 you'll be working with parabolas again. So let's just compare a little bit parabolas and the other conic sections we worked with, a couple of the other ones. An ellipse and a hyperbola have two foci. Parabola has one. Now, in addition to that, a parabola also has an axis of symmetry, a vertex, and a directrix. Now, it does not have a center. And each of these need to be graphed when you're graphing the conic section. So they need to be included on your graph. Now, an ellipse has a constant sum, and a hyperbola has a constant difference. But any point on a parabola is equal distance from the focus and a line dropped perpendicular to the directrix. So you're not going to be subtracting distances, and you're going to have a point and a focus and a point and a directrix. The other two conic sections, the ellipse and the hyperbola, you used a point and two foci. So there's only going to be one focus, but there is going to be another location, which is the directrix. So let's take a look at what that means. Now here you have all the parts that need to be graphed for your parabolas. And if you notice here, if I take a point and I go to the focus, a point on the parabola, and I go to the focus, and then I drop a perpendicular. Now this has to be perpendicular. It has to intersect. This is called the directrix at a 90-degree angle, then these two lengths are equal. So instead of adding or subtracting, what you're going to do is you're going to find the distance from here to here and set it equal from the distance from here to here. And when you do that and you simplify it, you'll get the equation for the parabola. So just keep in mind that this distance from here, so from the focus to a point, is the same distance as from the point to a point on the directrix that intersects the directrix at a 90-degree angle. Okay, now you need to determine if you have a horizontal or a vertical parabola. And to determine if you have a horizontal or vertical parabola, you look at the equation. Now I'm giving you a couple of other equations. Sometimes you're going to see parabolas in this form, and sometimes you'll see parabolas in this form. So if they are in this form, if the equation for the parabola says x equals, which it does here, that means the parabola is going to open horizontal because it's going to wrap around the x-axis. If the equation for the parabola says y equals, the parabola is going to be vertical. It's going to wrap around the y-axis. Okay, so horizontal, we need to add in here. This could open this way, or it could open this way, to the left or to the right. Vertical, we didn't go over these in Chapter 5, but we did go over vertical. So vertical can open down, or they can open up, depending on if this value is positive or negative. So if this value here is positive, the arrows are going to point in the positive direction if it's horizontal or vertical. So just kind of keep that in mind. If this is positive, point in the positive direction. If it's negative, point in the negative direction. Okay, notice P appears several times in the table to the right. I highlighted lots of them. And the reason why I wanted to do that is to make you aware of how often you have to use the measurement P. So the equations of parabolas use the parameter P, and the absolute value of P gives the distance from the vertex to both the focus and the directrix. Because remember, those lengths are the same from here to here and here to here. Okay, so let me slide this up just a little bit here. So the absolute value of P gives the distance from the vertex to both the focus and the directrix. Now that's very important when we go to graph. So when you're thinking about a parabola, you know you have to have the vertex, and you know you have to have a focus and a directrix, because any point on this parabola is going to be equal distance. We could pick any point, and if we draw a line to the focus and then again drop a perpendicular, so a point on the parabola to the focus and then drop a perpendicular to the directrix, those lengths are going to be equal. All right, so we're going to graph a parabola. And this is the one that we have to graph, and I wrote it in both forms. I have it in here with it just set x equals, and then I brought the 3 over here, so it's x plus 3 equals 1 over y minus 2 squared. Okay, this parabola has x equals. Another way you can look at it, whichever term is to the first power, that gives you the orientation of your parabola. Now, the parabola, if it's x or a horizontal parabola, could either open to the left or to the right. The way that you tell is you look at this value that's in front of the parentheses that are squared. If this is positive, it's always going to point to the right. If it's negative, it's going to point to the left. So this one is positive, we're going to point to the right. All right, so because the linear, or x is to the first power, this is going to be horizontal. And then we need to figure out how it opens. So because again, this is positive, it's going to open to the right. So this is how it opens. All right. So we're going to graph the vertex, and we're going to find the vertex the way that we found the centers, because here on a parabola, everything is measured from the vertex instead of the center. So just be real careful. The x-coordinate here is going to be -3. The y-coordinate is going to be 2. So we have -3, 2. And let's go ahead and graph that. At -3, +2. That's my vertex. I'm just going to put that there so I don't get confused with the focus. Okay, the axis of symmetry. If you remember on the first page, axis of symmetry, it's going to go right through the focus, and it's going to go through the vertex, so those 2 points, and it's going to be perpendicular, so there's another 90-degree right here. It's perpendicular to the directrix. So, we know that our parabola opens to the right, so we know that our axis of symmetry, or focus, is going to be inside here, so our axis of symmetry is going to look like this. Okay, so our axis of symmetry is going to go through our vertex. Actually, maybe I better make that red so you can see it a little bit better. It's a vertex. Now this is a line, so you have to say either x equals or y equals. Since it crosses the y-axis, it's going to be y equals 2. Okay, now P is used to measure a lot. It's used to measure the distance from the vertex to the focus and also the vertex to the directrix, because the vertex is the midpoint in between those two. So if you notice here, there's a 4P right here. So we need to solve for P so we can finish graphing the parabola. So what we're going to do is we're going to take this out and say, okay, well, 1 over 4P. Let's look at see what value this is replaced with in our equation. Well, 1 over 4P is replaced with 1/8. So what we can do is say 1 over 4P equals 1/8. We can do the cross product. So 8 equals 4P. And dividing by 4, P is going to equal 2. So that's going to measure from our vertex to our focus and our vertex to our directrix. So P is going to equal 2. All right, so the focus. The focus, if you're thinking about a parabola, let me bring this back over here. The focus is always inside the parabola, or the parabola wraps around the focus. So we know that the parabola faces this way. So that means if the vertex is here, the focus has to be to the right. So we're going to go to the right 2. So here's 1, 2. We'll put a point right here. And that's going to be at -1. And I'm just going to make an F there. It's going to be at -1, 2. The directrix is going to be the same amount, but in the opposite. direction. So we're going to go 1, 2, and that's going to end up right here at -5. And remember, the directrix is perpendicular to the axis of symmetry. So this is going to be a line that goes, let me make it a different color here. Okay, and these are perpendicular. Now this is a line as well, so we need to say either x equals or y equals, and since it crosses the x-axis, we're going to say x equals -5. Okay, so we know our parabola wraps this to the right. We know it wraps around our focus, but we don't know how wide it is. So just kind of like when we had the hyperbolas, we had to graph the asymptotes that would give us the opening of the branches. We're going to graph what's called the length of, or the latus rectum, which will give us the opening of our parabola. Okay, now the latus rectum gives the width of the parabola through the focus. Now make sure you're going through the focus. That's where it's measured. And it is represented by the absolute value of 4p. Okay, so we know what p is. See, p, we need to use p again here. So if we take 4 times 2, absolute value, that equals 8. Now that's the entire length. So entire length. So we have to, L-E-N-G-T-H, okay, we have to take the 8 and divide it by 2 because we're going on either side. So we're going to go 4 on either side. So from, not from the vertex, from the focus. So we're going to go 2, 4 here and 2, 4 here. So that means we're going to have, and I just realized that this scale is 2, not 4. So we're going to take this point off and this point off, and we need to go that's 2, 4. So 2, 4, so it's going to be up here, and 2, 4 down here. Okay, and then I'm just going to put a dashed line through the focus across to the other point here. And that means that the endpoints of the latus rectum, so, well, actually, let's go fill this in. This is 8 units, the entire length. So the points for the endpoints, I'm just going to put LR for latus rectum. The endpoints of the latus rectum are going to be at -1, 6 and -1, -2. Okay, now we know how wide that's going to open, so all we need to do is just go through the vertex and then through the endpoints of the latus rectum, and that's going to give us a more accurate idea of how wide that parabola is going to go. Okay, now you have U-triage to do.